Hey, so I wanted to talk about cross control stalls, just basically since that's something that CFI add-on students have to do for getting awarded their CFI and demonstrated to DPs. So the things I want to talk about is the two types of cross control stalls, the locations that they're most likely going to be encountered, the dangers associated with them, and then tackle some preconceptions and some myths. So the two types. So all cross control stalls are predicated on having two control inputs. So you're going to have an aileron input, and then you're going to have a yaw input, so a rudder input. When it comes to a skid, let's say we're going to do a left turn, so left wing low. So with that, a skid is applying rudder to put the nose inside the turn. So it would allow the aircraft to go like that. So you're going to put, for a skid, you are applying rudder onto the inside of the turn. As opposed to a slip, when we do slips, what we're doing is we're applying rudder to the outside of it. So where do we see these two locations? So generally what we're getting when you see a skid versus a slip, on the skid, as you work your spacing along the traffic pattern, so if you're going to go land at runway 8, as you work your pattern spacing, basically if you had winds that were pushing you towards the runway, you can put yourself into a skid. So skids are generally seen or applied as a technique for overshooting final. So as the student pilot rolls out from base to final, they realize that they're overshooting, and instead of increasing angle of bank, just using pure aileron, one control surface to get back on center line, they apply a rudder input to bring the nose alignment so that their sight picture remains the same. So they are fixing their sight picture, but not actually making safe and accurate corrections. So a skid is seen on that overshoot base to final. Whereas in a slip, you're going to see the slip cross control stall happen for things where we have high energy states. So high energy states are going to be those techniques that we usually do, so like short field landings or simulated engine outs, where you're going to have more of a steep approach and extra energy. So in that case, if we were going to do a left wing low, we would put rudder in that would essentially turn the nose outside of the turn, and then keep us on this constant angle. So where you're going to see a cross control stall in a slip is essentially as you get below glide slope, pulling elevator back to try and get back to the glide slope, and essentially stalling the aircraft by exceeding the critical angle of attack, putting in another course correction as they're in established slip. So here are the dangers of it. In all cases, when you have a stall, when we come to an impending stall, it's a symmetric loss of lift exceeding the critical angle of attack on both wings. When we do that at the same time, that is a stall. And we see a nose down motion, especially in the Cessna, where it's just a nice stable nose down motion. Whereas if you have an asymmetric loss, you will see the introduction of a spin, which will result in the nose low. The aspect of a spin being a asymmetric stall, the whole reason that we can remember that is for spin entries, we start with a stall, and then we apply a rudder input, which emulates our cross control, and that allows us to spin. So in both of these cross control stalls, what you're going to get is you're going to get the introduction of a spin, or if a spin doesn't develop into a skid, you'll get a deep spiral. But both of those result in tremendous altitude loss, which is significant when we're talking about both of these cross control stalls being encountered in the traffic pattern. So just two myths to kind of cover. The first myth applies to skids. The idea in a skid is that increasing the angle of bank, coming back to center line, would cause a stall by angle of bank means that student pilots will have a tendency to correct with rudder for their alignment. That is a false predication that stalls are caused by angle of bank. They're not. They're caused by exceeding the critical angle of attack. So for that reason, if you feel inclined to do a skid due to bad traffic pattern management, increase angle of bank, which you student pilots know how to do because we teach you steep turns, or just elect to do a go around. Go arounds are always free, and it's the best and safest option. Another myth that we see is when you are establishing a slip, if you're holding a constant energy state, you're holding a constant airspeed, and the point of intended landing is in the same spot on the windshield. If that point is moving up in the windshield, so you're going to land short, if your airspeed is increasing, that means you still have energy to correct. But if it's going up in the windshield and your speed is decreasing, it means you're losing energy. And at that point, do not use nose to correct to get to glide slope. Come out of the slip and bring that energy back, because a slip produces a tremendous amount of drag on the aircraft. And especially for those engine out approaches where you cannot use engine to correct glide slope angle. So those are the big things to cover on the cross control stalls, was the two types, a skid and a slip, the dangers of having it, and altitude loss, because our locations are predicated on most likely encountering these phenomenons in the traffic pattern, and then the myths that predicate doing a skid in the first place and for getting into a bad energy state on a slip. That's all she wrote.